Hello, my name is Taylor Allen. This is a fully functional machine learning pipeline built to train data in a seamless manner using multiple AWS services. Thank you for hearing my presentation today, and I hope you enjoy it. Before I begin talking about my practices, I would like to show you how the pipeline works in the state machine as a start. So this is a successful job. All we need to do is do a new execution. Our JSON input is already there, but it will prompt you to put in a dataset type in order to choose which path you want to go down. Concerning this model, there are two pathways to go down. So we will start execution, and then our execution started successfully. And so as I said previously, this is a pipeline built for training data at scale and creating an endpoint to interface with the data you have just trained. This is extremely useful for building multiple language models with efficiency as it accepts multiple formats. I chose to do this because I want to specialize in machine learning and AI. I've always had a passion for machine learning and the problems that it solves as a whole. The major features it has is efficiency, reusability, and scalability. This technique allows for multiple model deployment across regions in a one-click fashion. What is unique about the algorithm I built is that it allows for large data sets and multiple format data sets. The most technical challenge was learning Python on an advanced level. Before this, I had an intermediate at best knowledge of Python, so I really had to research concepts and libraries that were foreign to my knowledge. I will show my technical presentation and tutorial as well as how I use these concepts. And as you can see, our pipeline was indeed successful. So now I will briefly talk about the services that I used. I used an S3 bucket, which is a data storage for our training data, and it outputs the models as well. SageMaker was heavily involved in this, and as you can see, it just popped up. Uh, our endpoint was successfully sent for inference. So that we may invoke it, and this takes about 5 to 10 minutes, depending on what you're doing. Sometimes shorter, but we'll get back to that. So this is my Jupyter notebook. How I invoked the endpoint. This is specifically for the Iris dataset, which, as you can see, you can have different outputs based on the payload, which is enclosed inside of a data frame. So data frames are extremely important when interfacing and training a model. And this is our ECR, which functions much like a GitHub repository. It will you will upload the image of your code, and Lambda especially will invoke this image um, and essentially create the step functions for the state machine. And since I'm using Terraform, the Terraform from this image will invoke the S3, the step functions, and also the SageMaker, as well as policies and roles and permissions for said services. So I wanted to briefly go over my code, which this is this is the training of the model. This is really the meat of the pipeline, how the model is trained. And as you can see, here are our paths for SageMaker. And so this is our function for training the model. And as you can see, I have left comments. I will share my GitHub, and it's open to anybody who would like to use it. And I left comments for any user to kind of figure out what's going on. But this is for the JSON, it was a pretty big challenge to try and train the data. I had to add these especially for checking for not a number of values, checking for infinite values, and checking for extremely large values. But that also works for other large data sets that you may encounter. And label encoder is really useful because it transforms categorical columns, which are a real big problem in trying to transform your data to what you need it to do. There's pre-processing and post-processing of the data. Here is how we define the grid search random forest classifier. So um, usually you would have to put in hyperparameters, but I set hyperparameters because I feel like this is the most efficient way to train a model. And then it will evaluate the model and provide cross validation, and it will give it a score. So the best parameters and the best model will always be outputted, and then you can also see how well it was trained. So, and then if we go over to my main.tf, you can see that we are establishing all of these roles and all of these services in order to make AWS work for us based on what we need. I have a presentation slide, a note to user on how you can customize it based on your needs, explanation of practices. These are JSON inputs that we need to train the data, citations and Terraform documentation, and then an explanation of practices. So, and then also I have made a tutorial on how to do this for anyone to use. So that's my code, and that's my project. I appreciate everyone for paying attention and looking at my project. I really appreciate it, and it's been really fun to work on this project. It feels almost like a culmination of efforts and almost like a magnum opus for this boot camp. So thank you very much, and I hope you all have a good day.